Hello, it's time to talk about fractions. These things are also known as rational numbers. There'll be a test soon on this stuff, so we'll go over it now. Okay, and you can replay this video all the time, anytime you want. Okay, a rational number. A rational number is any number that can be written as a ratio of two numbers. That's where you get the word rational, because of the word ratio in there. Basically, any normal type of number that you've seen in your entire life. What is not rational? Things like pi and square root of 2. Things like that are not rational. But really, you haven't done much of those. So mostly every number you've ever seen is a rational number. Rational number are basically fractions or quotients of two integers. Okay, so good to know what examples of rational numbers are. Like 3. 3 is a rational number because any number like that you can always put on top of 1, and you have a ratio of two integers. 3 over 1 is 3. 25 over 17 is just a regular old fraction, clearly a rational number. 4 and 11/5 is what's known as a mixed number. It is a rational number because you can express it in terms of in a ratio of two integers. Okay, now there are three things you basically have to be able to do with these fractions before we get into all this other stuff. You need to know how to convert mixed numbers to improper fractions. In other words, numbers that look like that to numbers that look like that. You need to convert the other way, to go from improper fractions to mixed numbers, or numbers that look like that, and you have to know how to simplify fractions. So let's do those three first. Okay, the first thing is simplify fractions. Okay, why do you have to bother with this? It is standard math to leave fractions in lowest terms, just like it's standard English to capitalize names, right? It'd be weird to write an essay with the word Nancy Davidson and not capitalize the end of the D. Similarly, it's not a good idea to leave fractions that look like 486 over 1,000. Not good math. Okay, so how do you do this thing? How do you simplify a fraction? You look for common factors in the numerator and the denominator, and you divide the numerator and the denominator by these common factors. I think you basically know how to do this. So, and you keep doing this until you can't find any more common factors. So, for example, 468, you want to simplify. First you hit it by 2. And then you get 234 over 500. Then you hit them. Then you hit the numerator and the denominator again by 2, and you get 117 over 250. Turns out 117 is divisible by 3, but 250 is not. So we're done. Okay, it's a great trick, a really useful tip to be able to quickly tell if a number is divisible by 3. You add up the digits, and if the digits are divisible by 3, then the number is divisible by 3. For example, if you look at this improper fraction, 87 over 9, you look, well, 9 is divisible by 3, so you ask yourself, is 87 divisible by 3? So you add the 8 and the 7, you get 15. 15 is divisible by 3, so 87 is divisible by 3, so you can divide both numerator and denominator by 3, and you simplify it. Okay? Now, so that's simplifying fractions. You must leave fractions in simplest terms, otherwise you may get a point off, and you may not get an E on that question. That would not be good. Now you have to know how to convert a mixed number to an improper fraction. A mixed number is like 4 3/7. You know, it's like you have $2.25 in your pocket. You have $2 bills and a quarter of a dollar. It's a mixed number. You have to know how to convert it to a fraction. This is important in adding and subtracting, multiplying, and dividing fractions. Okay, so what does 4 3/7 mean? 4 3/7 really means that it's 4 plus 3/7. Okay? So the formula for doing this is you multiply the 4 times the 7 to get 28. You add the 3. You put that in the numerator, and you keep the denominator as 7. See? N times D plus M over D. Okay? So how do we do this? In example, 4 and 3/7 means 4 whole things plus 3/7 of a thing. So 4 whole things basically are 28/7, right? Because 4... you want to figure out how many sevenths are in 4 whole things. You multiply the numerator by 7. So you have 28 over 7, really means 4 whole things. Plus, then you have an additional 3/7, and you get 28 over 3 to get 31. I'm just trying to sort of explain what this stuff means, okay? So that's how you do this. You multiply you multiply this whole number by the denominator, and you add the numerator, and you put it all over the denominator, okay? That is how you do this, okay? You always are adding. You're always adding, right? Always adding. Always adding. Okay, now how do you go the other way? How do you go from an improper fraction to a mixed number? Oh, this is a little harder. This is a little harder. You start with the 37 over 7. What is the highest number less than 37 that is divisible by 7? Okay? So you ask yourself, what is that number? Oh, it turns out to be 35. You can always start with 37. Nope, that doesn't work. 36. Nope, that doesn't work. 35. 35 is divisible by 7. Beautiful. And there are 5 sevenths in, there are 35 sevenths, and there are, so anyway, 35 divided by 7 would be 5. In other words, there are 5 whole numbers in 35. It's hard to explain, right? But you know what I mean. How many sevenths are there in 5 whole things? There are 35 sevenths in 5 whole things, right? That's pretty clear. Okay, so you have 35 things. 35 divided by 7 is 5, and then you have 2 sevenths left over. So that is how you do this, right? You figure out how many whole numbers there are, and then the leftover is the fraction. Okay? Now, you could save yourself a little bit of heartache if you have a problem like this, 112 over 36. It's really pain to say, well, how many 36ths are there in 112, and 111, 110, 109, 108? It's a real pain. So if you have numbers like this, notice that you could simplify them first, right? They're both divisible by 2. They're both divisible by 2. So definitely do this. Make it simplest form before you try to convert it to a mixed number. Always get confused between the mixed number and the improper fraction, as you can tell. Divide by 2, right? So it's 112 divided by 2, 36 divided by 2 is 56 divided by 18. Look at that. You could hit it again by 2, right? So you go 28 by 9. Now, all of a sudden, this is a lot easier. It's a lot easier to deal with this than it is to deal with this. So you start out, well, 28, 9 does not go into 28 very evenly. But what about 27? 27 is beautiful. So you have 27 ninths, which is 3, and you have 1 left over, 3 and a 9. Okay? So that is how you deal with that stuff. Okay? Now, all fractions can be written as decimals, and all decimals can be written as fractions, right? Now, see, so on this side, on the left side here, all fractions can be written as decimals. If you have there are 2 ways, there are 2 decimals you can get out of these things, right? You can get a terminal decimal or a repeating decimal. But the bottom line is, the way to do this is the way that always works is long division, right? You can always sit here and do long division, which is a pain. This one, unfortunately, you have to do long division. If you have problems like these, 20 over 100, 35 over 25, if you can get the denominator to be 100, then the problem becomes a lot easier, right? Because 6 and 20 hundredths is just 6.2, right? Because you divide by 100, you get 6.2. So that's great. Now, if the denominator is a factor of 100, then it works out really well, because you could say, well, negative 3 over 25 equals how many hundredths? How many hundredths? So it turns out to be 12 hundredths. So the answer is negative 0.12. If the denominator is not a factor of 100, then you basically have to do long division, okay? But remember, if you ever had to do this on a test, make sure these numbers are in lowest form. Actually, for here, 20 over 100 really was 1/5. But actually, no, you want to leave it as 20 over 100, because when you have something over 100, it's a real gift, because it's just 6.2. But in a problem like this, you're stuck, because 3 doesn't go into 100. So you have to do long division. Boo-hoo. You just set up the long division, and then you'll notice that you will be getting a repeating number, repeating decimal. Okay, so the answer is 11.6. All fractions can be written as decimals, they are either going to be terminating, which is this thing, right? They terminate, they don't repeat, or they repeat. Got it? Okay. Why bother do this? Why do we bother do this? Well, because it's much easier to deal with a decimal on a calculator. If you type in a decimal on a calculator, you don't get a if you type a fraction in the calculator, you don't get a fraction, you get a decimal, and the calculator really shows you what the decimals are. So calculators work in decimal. That's why you need to sometimes convert a fraction to a decimal. Actually, if you use a calculator, you really never have to do this. The calculator can do this by itself. You just type the number 35 divided by 3, and the calculator will spit out at you 11.666666666, whatever. Okay, now, you have to go the other way too. All decimals can be written as fractions. So if they give you a decimal, and you have to write it as a fraction, you have to know how to do that. Now, if it is a terminating fraction, you are a lucky person, because a terminating fraction is really easy to convert. No, a terminating fraction, God. Terminating decimal is really easy to convert to a fraction. All you do is you look at this thing, and however many places there are, that's the power of 10 that you put in the denominator, right? So if it's 5.28, there is a hundredths place, right? The 2 and the 8, that means a hundredths place. That means you put the 28 over 100 and you're done. So it's 5 and 28 hundredths. Then you have to simplify that. Don't forget to simplify, right? Don't forget to simplify. You hit each side by 2, and then you do it again, right? Okay, right, for 7/25. So same thing here. A 7 it's only the tens place, so it's just 7 over 10. Done. 82, just like this one, except the digits are reversed. You do 82 over 100. Right? Exactly. I think I have an example. Oh yeah, look at this one. 0.895 goes to the thousandths place. So you just type 895 over 1,000. Problem done. Those are easy. Okay, now the problem though is when you have a repeating fraction, how do you turn that? No, get it again. When you have a repeating decimal, how do you turn that into a fraction? That will be a separate video. Okay? You don't do this too often in real life. In fact, you almost never do this in real life, but you'll have to do it for the test. So this will be a separate video. Okay? So we're basically done with all this sort of boring stuff having to do with fractions, right, and ratios and all the rational numbers. Now let's do what really is important. How to deal with these things in equations, although we're not having to do equations yet, but you have to have this skill in order to deal with fractions in equations, which is going to be the topic next week. Okay? So, you have to know how to multiply, add, and subtract fractions. And next week we'll be dividing fractions. Okay? Multiplying fractions, really, 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 really easy. It's just a quick formula. A over B times C over D is AC times AC divided by BD. You just multiply the numerators, keep them as the numerator, multiply the denominators, keep them as the denominator, and then simplify. Always, always, always convert improper fractions to regular fractions. No, mixed numbers. Sorry. Always convert mixed numbers. Look at that. Always convert to improper fractions. You got to go from mixed numbers to improper fractions all the time. Okay? So here's our super easy examples. 1/2 times 3/7. Multiply the 3 times the 1 and the 2 times the 7, you get 3/14. You have a negative number here. Negative times a positive is a negative, so the answer will be negative. You multiply the numerators, the denominators, and then you get 2 over 14. Then you have to simplify. Don't forget to simplify. Here you have a mixed number. Okay, I got that right. I didn't say improper fraction. I said mixed number. Here's an I almost said it. Here's a mixed number. And there's a negative sign, so one negative sign, so the answer will be negative, right? And so you have to convert this and this to improper fractions, doing it what we did before. You just do all that, and you get negative 39 over 8 times 11 over 3. Now, you could multiply 39 times 11. That's a pain. Look for being able to simplify ahead of time. Look at this. 39 is over here, but 3 is over here, and you can actually simplify because there are 3 goes into 39 evenly, right? So you actually have 13 of these things. So there's 13 times 11 divided by 8. 13 times 11 is a little easier than doing 11 times 39. And then you can do that, and you get 153 over 8. Does not look like you could simplify this anymore. You may have to leave this as a mixed number. I didn't do that. Not sure, but certainly 153 over 8 is an answer. If the teacher wants you to convert it to a mixed number, then you would, let's see, 20 of 20 times 8 is 160. So I would try like 18 or 19 times 8, maybe 152. So it's probably 19 and 1/-19 but you can test that out, okay? During the test, you may want to ask, can I leave this, or do I have to leave it? Do I have to put it as a mixed number? But in any case, the important thing is the multiplication, right? Multiplication is very, 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 very easy with fractions. Any number, any fraction can be multiplied by any other fraction. You just multiply the numerator and the denominator, and that's it. And don't forget to convert to normal fractions. I call them normal fractions, but you know what I mean, improper fractions. Regular old fractions with a number on the top and a number on the bottom. Now, adding and subtracting fractions. This is more of a pain. You must have a common denominator, okay? Must have a common denominator. So if you're lucky enough to have a problem with a common denominator like this one, 3/10 plus 6/10 is 9/10, you just add the numerator and you keep the denominator the same, obviously, right? Because you're adding 3/10 and 6/10, so you have 9/10. These are almost like terms, right? Think of it as like terms. 3x and 6x is 9x, right? 3/10 plus 6/10 equals 9/10, right? Now, when you have mixed numbers, remember, convert to normal fractions and then do the work. This is a number minus this number, so we convert them to improper fractions. The 46 is bigger than the 39, and there's a negative sign there, so this number is -7. Cannot be simplified. This one here, again, you do the same thing. This is a negative minus a negative, right? So it's a negative minus a negative. So basically, you'll be adding these two numbers. They're friends. They're the same sign. You add them, and then at the end, you give it a negative number, right? You give it a negative sign. Okay, so that's it. Yeah, you just convert here to improper fractions, and then you just add them up. There's a 28, and there's a... oh, wait, I just want to make one other point here. You see, these had common denominators. These did not have common denominators. Okay, so this is important. I'm sorry I missed this. You must have a common denominator. So you must convert. After you convert these guys, or these people, these things, whatever they are, they're not really guys, they're numbers. After you convert these numbers to improper fractions, you'll notice that the denominators are not like. See, that's a 4 and that's a 3. You cannot add them. You must have a common denominator. So you have to convert. You have to convert 31/4 and 7/3 to fractions with a denominator that's the same common denominator, right? So you look at these things and you say, what number can I multiply by 4? What number can I multiply by 3 so that I get a common denominator? And it turns out that, well, the number would be 12 is a reasonable number. It's actually the lowest number that's good. It's the lowest number that shares these two numbers, right, as factors. So you would then force it. You need to have a 12 in the denominator, right? You've got to have a 12 in the denominator. So how do you turn 31/4 into twelfths? Well, if you multiply the denominator by 3, you've got it made. But then you have to multiply the numerator by 3. Otherwise, you got a problem, right? So you have to multiply top and bottom by 3. This one here, look at this. What number do you have to multiply by 3 to get 12? Well, that's 4, right? 4. So you have to multiply 7/3 times 4/4. That's why you have to know how to multiply before you know how to add. Okay? Very often you do adding first, but it turns out you actually have to really learn multiplying first, right? Because you can't multiply, you can't do this unless you know how to multiply fractions, right? So here you do 3 times 31, unless I made a mistake, it's 93 and 28, and then you add them together because they share the same sign, and you get the answer. Okay, so this is basically all you have to know about fractions. There'll be a second video on how to do this stuff. Right over here, this stuff. Okay, good luck.